This diagram maps the standard AI pipeline. An issue is logged, an AI proposes a fix, a human skims, and code merges. The AI generates blocks seamlessly. Because the output looks complete, the human's read is shallow, approving flaws because they appear finished. Subconsciously, a single reviewer asks, "Could this be right?" That plausibility check resolves to yes far too easily. To actually find bugs, the reviewer has to ask, "What breaks this?" A single plausibility check produces a specific failure mode, the correct-looking artifact that is fundamentally wrong. The pipeline quietly ships systemic flaws into production environments. Scaling AI code generation safely requires abandoning single-pass plausibility checks entirely. We replace that linear pass with an adversarial council. This is a heavy, multi-gated overlay sitting squarely across the deployment path. Within these gates, planning and review are structured as parallel teams. Each node represents a distinct, machine-enforced, antagonistic perspective tasked with finding failures. You establish a deterministic trust layer over probabilistic AI models by replacing a trusting human skim with mechanical antagonism. Assigning an AI the generic instruction to review this code simply recreates the human's plausibility bias in machine form. It optimizes for polite approval. This diagram shows the required countermeasure, shattered distributed review. The generic task is broken into hyper-specific lenses, like right correctness. Their identities are not arbitrary. Each is a manifestation of a specific historical failure class that has cost this repository in the past. Every lens receives a strict operational directive. They act as explicit adversaries, defaulting to skepticism, solely hunting for their assigned failure class. These adversaries execute their checks in parallel. They remain completely blind to each other's work, ensuring an early approval from one lens does not anchor the reasoning of the others. To function properly, every reviewing lens must operate under a strict, non-negotiable constraint. They are read-only. If an AI agent is allowed to automatically fix and merge the code it reviews, the separation of concerns immediately collapses. The reviewer becomes the author, and the adversarial tension is lost. The model enforces strict grounding. Every claim must cite a specific file path and line number. We enforce these findings with a mechanical verdict system. If one single lens out of the entire panel issues a block command, the pipeline immediately halts. This halt is absolute. It is a rigid, machine-enforced rule, not a consensus vote or an aggregated score. One credible citation of a break stops the train. Shifting review from a single generalized pass to a team of read-only, veto-empowered specialists systematically counters the plausibility trap. A bug in execution creates a bad commit, but an architectural plan that misidentifies the root problem, even if perfectly implemented, is the most expensive possible error. It is caught only in a production environment. This diagram visualizes the architectural solution to that cost asymmetry. The adversarial panel is duplicated to form two distinct structural gates, one for the plan and one for the code. We can observe these gates operating on a real-world case from the Metascope repository. An issue ticket reported a sync all dates operation silently dropping data without indicating which files failed or why. The AI orchestrator consumed the issue and generated an initial plan. It assumed the failure reasons were lost downstream at a process layer and proposed bundling a new software flag to catch the drop. Before code is written, the plan hits Gate 1. The diagnosis lens actively cross-references the proposal with raw source code. It issues a mechanical block, proving the AI mislocated the bug. The data is actually discarded upstream at a specific choke point. Gate 1 mechanically blocks the artifact. The orchestrator is forced into a cheaper, upstream revision, hardening the approach while it remains a text document. After clearing the plan, the orchestrator writes the actual fix. This smaller, verified code payload moves downstream and enters Gate 2, the review panel. Inside Gate 2, the test reality lens raises a block. It cites a highly plausible argument. The fix appears to only catch failures in 1 out of the 10 possible operation types. The AI orchestrator does not blindly comply, nor does it dismiss the block out of hand. It reads the shared process manager and grounds its response, proving the lens's premise was factually false because a universal throw path covers all operation types. The dual-gate system intercepts architectural drift early while forcing downstream review disputes to be resolved through evidence cited directly from the source. Theoretical review processes that rely entirely on human discipline are fragile. Under severe deadline pressure, optional checks are always skipped. This visual details structural enforcement. A Git hook intercepts a commit, reading a JSON manifest tied to Get hashes. If a developer alters the code after an approval, the hash goes stale. The hook mechanically blocks the merge until the council runs again. With gates structurally unavoidable, focus shifts to system evolution. How do you prevent a rigid council from degrading into a stagnant, outdated checklist? We introduce the Observer. This independent agent node solely audits bypassed gates and reviews production bugs that escaped the panels. When a failure class slips through, the Observer catalogs it as an unowned gap. Once evidence shows 2 escapes from the same gap, it officially proposes hiring a new permanent lens. The Observer also corrects for systemic blind spots. Identical AI model families will share the exact same reasoning flaws when evaluating abstract system contracts. The surgical counter to this shared blindness is routing the highest stakes artifacts through a synchronous cross-provider check. This forces a completely different model family to verify the logic, leveraging diverse blind spots to find integration gaps. Cryptographic Git enforcement prevents the process from being skipped. Combining that with an independent self-auditing node turns a brittle pipeline into a living defense system that hardens itself after every failure. Implementing this playbook restructures the division of labor between human engineers and machines. The scope of AI autonomy is vastly expanded. The agent now owns the engineering pipeline entirely end-to-end, moving from planning to synthesizing mechanical verdicts to executing the final merge. In exchange, the human boundary shifts. Human engineers are deliberately and completely removed from routine plausibility checking and line-by-line code review. This diagram shows where human expertise is reallocated. The engineer moves up the stack, focusing entirely on architecting the rules of the gates and managing the historical failure roster. The human retains absolute authority over high-leverage interventions, deciding genuine product forks, defining release scopes, and explicitly approving irreversible actions. By offloading the burden of plausibility to an adversarial machine council, engineering teams systematically scale the AI speed and the human's architectural authority without ever sacrificing production trust.